Good morning. Myself Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the stick diagram from Unit 1, that is MOS transistor principle of VLSI design subject. Let I discuss. These all are the topics to be covered by this lecture video. Yeah. Stick diagram introduction. A graphical representation used in semiconductor design is depict the arrangement of layers and connections without detailing the actual dimensions, which is called stick diagram. This is intermediate representation between circuit diagram and layout. And simple design is sticks layout. Metal wire, VDD is power supply, poly is polysilicon, which is gate, N diffusion source, NDIFF, PDIFF, P diffusion drain, VSS ground, A comma B input, Y equal to output. You can see symbol and stick diagram of two input NAND gate. Okay. Okay. CMOS inverter. The CMOS inverter is a fundamental building block in digital electronics, widely used for its low power consumption and high noise immunity. It consists of both PMOS and NMOS transistor connected in series between power supply and ground. Mapping a stick diagram to CMOS circuit. Here you can see PMOS and NMOS, and upper part is VDD and lower part is ground. This represents the physical layout of transistor and interconnection in a CMOS inverter or other CMOS gate. Next is NMOS inverter. In a stick diagram representation of an NMOS inverter, a vertical line with a circle represents the NMOS transistor. The drain is connected to ground and the source is connected to output. The gate of the NMOS transistor is connected to the input. Static CMOS NAND gate. You can see the truth table. Pull down, connect to ground if A equal to 1 and B equal to 1. And operation. Pull up means connect to VDD if A equal to 0 or B equal to 0. A static CMOS NAND gate is constructed using combination of series and parallel connection of NMOS PMOS transistor to achieve the NAND logic function. Static CMOS NOR gate. Similarly, a static CMOS NOR gate utilizes series and parallel connection of transistor to implement the NOR logic function, ensuring both NMOS and PMOS networks work together to achieve the desired logic output. Pull down, connect to ground if A equal to 1 or B equal to 1. When pull up, connect to VDD if A equal to 0 and B equal to 0. You can see the NOR gate structure. Okay. Static CMOS example with static diagram. Static CMOS design example with static diagram. Transmission gate style utilizes transmission gates which is composed of NMOS and PMOS transistor to pass or block signals based on control signal suitable for high speed application. Pull up network style employs a pull up network using PMOS transistor and pull down network using NMOS transistor to achieve robust logic level and noise immunity. Here diagram 2, complex logic gates layout. Similarly, next is Euler paths. Okay, Euler path definition is, yeah, an Euler path is a trail in a graph that visit every edge exactly once. Uh, in graph theory, an Euler path is a trail in a graph that visit every edge exactly once. If a graph has an Euler path, it means it is possible to trace a path through the graph that covers all edges without retracing any edge until all edges have been traversed exactly once. Vertex connectivity for an Euler path to exist in a graph, the graph must be connected exactly 0 or 2 verticals should have an odd degree. PMOS and NMOS. This notation indicates only the relative positioning of the various design components. The absolute coordinates of these elements are determined automatically by the editor using compactor. The compactor translates the design rules into a set of constraints on the component position and solve a constrained optimization problem that attempt to minimize the area or cost function. This is the Euler graph stick diagram comparison. Yeah, CMOS inverter color stick diagram. This is the assessment. Draw the CMOS inverter stick diagram. Draw the CMOS NAND gate and tell me the color coding name. These three are the assessment of this lecture video. If you have any doubt means you can ask me through the comment. And advantage and disadvantage, designer does not have to worry about the design rules because the compactor ensures that the final layout is physically correct. And disadvantages is the outcome of the compaction phase is often unpredictable. The resulting layout can be less dense than what is obtained with the manual approach. It does not show exact placement, transistor size, wire length, wire width, top boundaries. Okay, we will meet in next video lecture. Thank you.